Let's step through the branching lab. So for this lab, there is some starter code, branchinglab.cpp, that you'll be using, and you'll edit this file and then turn in the same file. So we have starter code. Here's information on the project setup if you need to create the project from scratch, or you can type out everything if you wanted to, and I have main already set up. The way we're going to think about this is each of these, we haven't talked about functions yet, but these are their own little, for the time being, little like standalone programs, and each of these are being called in main. So you're just going to be working inside of these. So you don't need to modify main, you'll just be running this, and it'll ask which program do you want to run. So if you typed in 1, it would run program 1. If you typed in 2, it would run program 2. And down here, we would have our branching lab. Now, I don't know why this starter code starts with that. It doesn't in here. We're just going to get rid of that right now. So the first part is the hometown. We're just using a simple if statement. We need to ask the user to enter their hometown name, but we're not going to deal with spaces right now. Then we'll display either that's a long name if it's over a certain amount, or we just won't. And then we'll also ask for their name and then display all that information. So that kind of steps through it, and then there's reference information down here. So there's a lot of information about how strings work, how to get the size of a string, how to check the size of the string, how to get input for the string, how to get spaces if you wanted to get spaces in the string, but then also the step-by-step and how to test. So don't just stop at the first page of the lab. Make sure to go through and read through the entire part of it before continuing on. So if we look down here, we're going to need string name, string hometown, and then looking at the program flow, we declare the two strings. We'll output the text, enter your hometown. So output to the screen means we need to use a cout statement. Get input from the user and store it in hometown using the cin statement, so console input, storing into the hometown variable. And now if the string length of hometown is more than 6 characters, then we'll output that's a long name. So how do we get the length of that string? Well, up here it talks about using the .size function. So hometown .size, if that happens to be greater than 6, then we're going to display a special message. We have this here. We could get the string and then output the size if we wanted to, but we don't want to actually output the size. They don't care about it. We just want to check if the size is greater than 6. We can store the size in a variable, an integer variable if we wanted to, or we could just directly put if hometown size is greater than 6. So if it is greater than 6, we're going to output that's a long name. If it's not greater than 6, if it's less than or equal to 6, it's not going to display anything special. It's just going to continue on with the program. Next we'll do enter your name and do a cin statement for the name. And then finally we'll output some text, hello name from hometown. And we're going to swap out that square bracket name with the actual variable value from, and then the hometown. And then that is it for that program. We can run it. Run number 1, hometown. Let's say Raytown. Oops, I accidentally put an extra E at the end. So then it would say, that's a long name. What's your name? Hello, Rachel from Raytown. And then there's a set of tests. So how do we know if it's working? Well, it shouldn't display the special message if we have a small name for the town. But if we display something with exactly 6 characters, so we'll just do 1, 2, 3, 4, 5, 6 is the hometown, it's also not displaying. It should only display once the length of the town name is greater than 6. So if we had a town name with 7 characters, then it would display it. So we have 3 different test cases here to test it out with, and that's one way you can make sure that your program is working properly. Okay, so that was program 1. Let's look at program 2. Each of these are doing different types of if statements. This one is going to use if and else together. We're going to ask them how many points total for an exam, how many points did they get, and then figure out if they passed or failed. So again, there's reference information. How do you calculate a grade out of 100%? What is an integer? What are we using integers? Should we use floats? But down here it has the specifications. So first we'll create these variables: user points, total points, and grade. We'll ask the user how many points their assignment was for and store it in the total points. So that's basically 2 steps in one instruction. So how many points was the assignment? Get input and put total points. How many points did you score? Input and get into user points. And then it'll calculate the grade. We don't need to output it quite yet. But we can say grade is equal to user points divided by total points, like 8 out of 10. And if we wanted it to be 80% instead of 0.8, we would have to multiply this by 100. So, for example, if I output the grade as it is, and we say we got 8 out of 10, it's going to give me, oh, I did that backwards. If the assignment was for 10 points and I got 8 points, it would give us 0.8. Like, that's the 80%. But if we want to make it look nicer, like 80%, we have to multiply it by 100. So 10 points got 8, that's an 80, and then I could output a percent sign at the end to make that a little bit more clear. 80%. But what we also want is to say if they passed or failed. So let's go ahead and just say your grade was whatever percent that was. I'm also going to add some end line just to make it look nicer for the user. If the grade is 60 or above, then we'll output you passed. Otherwise, we'll output you failed. So if grade is greater than or equal to 60, this will occur. The opposite is if grade is less than 60, then this will occur. So if we run this, let's say it's a 10-point thing and we did 6 points, so we passed. We will run the program again. 10-point assignment, we got a 5.5, so we got a 55%, so we failed. And then again, we have some tests here. You can see if it equals 60%, it should give you a passing grade. If it's above 60%, it should be passing. And then if it's below 60%, it should be failing. Okay, next one, we're using a bunch of if and else if statements. We're just going to ask the user for what their phone charge is and then draw a different little diagram based on that. So we'll have a integer variable named charge, and we'll ask the user how much charge does your phone have? Get their input, stored into charge. And if their charge is greater than or equal to 75, we will display a full battery. Otherwise, if the charge is greater than or equal to 50, we'll display maybe 1 pip gone. We can do that, or we can do like the underscore here. So how do we know that this is going to be greater than or equal to 50 and less than 75? Well, the if statements execute in order. So if this one didn't get executed, then that means charge is less than 75. What is it exactly? I don't know, but if this fails and then this passes, then that tells us that charge is also less than 75 and charge is greater than or equal to 50. So we don't have to write a whole extra set of if statements, or we don't have to write charge is less than 75 and charge is greater than 50. It will implicitly do this for us. Okay, else if charge is greater than or equal to 25, then we're going to display with 2 blanks. And again, this means if this doesn't pass, that means it's less than 50, and then here maybe it's greater than 25. Else if charge is greater than or equal to 5, we'll output with just its last little bit left. And then otherwise, if none of those passed, then we are going to say it is empty, or basically empty. So in this case, if it were, let's say 2 is not greater than or equal to 75, pass that one. 2 is not greater than or equal to 50, pass. 2 is not greater than or equal to 25, pass. 2 is not greater than or equal to 5, pass. So the only thing left is the else case. Otherwise, it would have passed with one of these up here and done one of those outputs. So we can, there's a bunch of test cases you can do here, but we'll just do a few of them. How much charge? 100%. Okay, how much charge? 75%. Well, that was at the very bottom of that range. How about 70%? How about 23%? And so on. So we have different battery charges there. Okay. Number 4 is input validation. This will be actually very handy. We will often want to make sure that the user's input is within a specific range, like a valid range, before continuing on with the program. So this is just a quick introduction to that. So this program will ask, what's your favorite this or that? Give them a list of options, and then if they try to choose outside of that list, we're going to tell them that's an invalid choice. So in this case, we're going to go over what is valid and invalid. How do we know what is valid or invalid? And we're using ranges here because numbers are just easy to work with. And then how do we detect if it's invalid? And which is the best method to use, which I would use the range-based one here and here. So we can either check, is the input valid? We could do if input valid or if input invalid, and we could write them in either way. Well, first we need to have int user choice and then the program flow. We'll say, what is your favorite type of book? And we'll display a list. And we'll have them enter their choice. Okay, so if we want to detect if these are valid choices, we can say if user choice was 1, or if user choice was 2, or if user choice was 3, or if user choice was 4, then it's a valid choice. But if we kept adding onto the list, we wouldn't want to have to write this out as like 1 or 2 or 3 or 4 or 5 or 6 or 7. Maybe if you only had a few options, that would be fine. But it would be much easier to take advantage of these being numbers to say if the user choice is greater than or equal to 1 and user choice is less than or equal to 4, it's within that range, then it's valid. Why aren't we using or? Because if we did that, we would be saying user choice is greater than 1, so everything over this way, I'm not sure, the camera will be weird, it'll look funky, but if we had greater than or equal to 1, we would have everything this way, less than or equal to 4, everything that way. If we said or, it would give us basically infinity. It would go all numbers, because all numbers are either greater than or equal to 1 or less than or equal to 4. That would work with all numbers. So we're putting and, so a number 2 is greater than or equal to 1, and it's less than or equal to 4, so that's a valid choice. -5 is not greater than or equal to 1, but it is less than or equal to 4, so we don't want the OR case there. In the other case, down here, if it's not valid, we want to display invalid choice. So that's one way we can detect these. We can also detect if invalid instead. So if user choice is outside of that, 1 is the first option. If it's 0 or less than that, if it's less than the minimum, then it's invalid. Or if user choice is 5, if it's greater than that maximum, then it's also invalid. If user choice is greater than 5, then this is an invalid choice. Otherwise, then it is a valid choice. So we can double check these in either way. You could have just this one or just this one. But now it'll display it twice. So we'll run this. Number 4, if I say 5, invalid, that's not right. Oh, the problem here is I put 5 as the thing. Okay. If we run this and we put 5, invalid choice. If we run it again and put 2, that's a valid choice. Okay. And then there are a bunch of test cases you can go through to test those out. Okay, finally we have a calculator program. We are going to go through these. We'll ask the user to enter 2 numbers and then what type of operation, and then we'll do that math. So we'll use a switch statement here. There's some information about how the switch statement works, how switch statement flow through works, and what we should do for division by 0. So we'll start off with creating our numbers, num1, num2, result, and char operator. Well, that seems to not like that. That's a keyword. Maybe I should just name that OP. And then we'll go through the program flow. Enter the first number, enter num1, enter the second number, num2, and then operations. Plus is add, minus is subtract, star is going to be multiply, and slash is divide. Which operation, and enter into the op variable. So then, based on that, we can have a switch statement based on the operator that they entered. So if they said case plus sign, we'll do one set of things, case minus sign, another set of things, and so on. So multiplication and division. And so this kind of goes over using a switch statement again. We will do the math based on what they said and then display the result at the end. Cout result, result. Okay, so if they chose to add, we'll say result is equal to number 1 plus number 2. If they chose to subtract, we could say number 1 minus number 2. Multiply number 1 times number 2, and then in this case we don't want to divide by 0, so we could add if number 2 is 0, we don't want to divide by 0. We'll just say result is 0 for now. We don't have a good way to really deal with this error, but we'll say cannot divide by 0. Otherwise, if it's not 0, it's fine to divide. So result is num1 divided by num2. And then we'll get the result at the end. So we run this, program 5, let's say we'll do 5 and 8, and we will multiply, and it gives us 40. let's do 8 over 9 and divide. Okay, let's do 8 over 0 and divide. It'll give us the result 0, but it'll have that error message, cannot divide by 0. And we haven't done anything for if we type in some other operation that doesn't work, like this, it's not going to do anything. Also, well, because I put more than one letter in there. But we can have a default case for basically the else case. Invalid operation. So we run this, and if I put in two numbers, but then I type in a ampersand, it's going to say invalid operation. Also, result is going to be a bunch of garbage, but they didn't enter a valid value anyway. So then there's that, and you can test that out. So that is this lab, the branching lab. Hopefully that all makes sense. Again, don't just watch the video, make sure to read through the instructions as well, because it has a lot of information about how things work and why they work that way. But this is at least to get you kind of oriented in how these programs are being written.